Application of the engineering design process to the physics classroom. Engineering design refers to design principles and processes used by engineers and other scientists aimed at solving problems. While engineering is complex and this is a flexible process, the image on the right identifies the basic structure. Identify the problem, explore, design it, create, try it out, make it better, and then repeat this circle as needed. The process shown on the last page can be used to solve many kinds of problems, including developing methods for disposing of nuclear waste, designing new systems for electric vehicles, making more efficient transmission of electricity, determining how to manufacture an item on a mass scale, planning the best way to mitigate excessive greenhouse gases in the atmosphere, creating more environmentally safe refrigerants. At the classroom level, students can research these problems and use simulations and simple projects to solve small segments of them. If that is possible, they can then use a methodology to create reports on how the problems can be addressed. The first step in solving a problem is identifying the problem. That is, what is the problem you're trying to solve? In doing this, it's critical to determine the success criteria. How will you know the problem has been solved? And to identify constraints that will be working against you. Clearly identifying the problem, determining what parts of the problem you can solve and what can't be solved, and how to evaluate the problem has been adequately solved will ensure that all stakeholders are working together towards the same endpoint. Once the problem has been clearly defined, it's time to do research to see if others' past work can be used to help solve the problem. This step might include reviewing research articles, talking to colleagues or others who have done similar work, and identifying existing similar technology that could be used as a springboard to solve the new problem. Innovations in one area of science and technology often drive innovation in other areas. Teams typically collaborate to design a potential solution to the problem. This part of the process may rely on technical drawings, blueprints, flowcharts, budgets, etc. Team members will try to anticipate problems that might occur so that they can account for them in their plans. It's much easier and less costly to design with potential problems in mind rather than address them as they occur. When designing solutions, teams must continue to hone in on designs that will meet the success criteria determined in earlier steps. Last 3 steps. Create. Once a design has been agreed upon, it's time to build a prototype or jump directly into a first iteration. This prototype or first iteration gives a starting point from which to work on refinement. Next, try it out. During this stage, teams look for ways to improve the design or maximize the output. These trials lead to systematic modifications and improvements to the design. Even if early iterations prove promising or work, adjustments can still be made to improve performance and ensure that the success criteria identified earlier in the process are met. And finally, make it better. Teams implement ideas for improvement. It's important to note that this process isn't always linear. Sometimes there are multiple iterations to identify and implement ideas for improvement.